Hello students, happy morning. Class 12 Physics, Unit 1 Electrostatic revision classes is going on. In our previous class, we discussed the subtopic, that is historical background of electric charges and Coulomb's law. Okay, in that topics, we discussed the book back questions alone. Okay, from today's class, let me see the questions from electric field and electric field lines. Okay, only book back questions. Okay, first question, that is define electric field. Okay, define electric field. That is a very short answer question. Very short answer question. First question, define electric field. Simply electric field. Electric field is represented by the symbol E vector. Okay, because electric field is a vector quantity. To answer this question, you have to know what is electric field. Okay, if suppose I consider a source charge Q. Okay, this source charge is nothing but a positive charge. Okay, from the charge at a distance R, I plot a point P. Okay, I need to find the electric field at the point P. Okay, this is electric field at the point P. So I am placing a test charge, okay, Q0 at that point P. So this test charge experiences a force. Okay, if suppose here the source charge is positive and the test charge is negative. Okay, then the negative charge will attract towards the positive charge. Okay, so it experiences a force. Okay, we can state electric field is a force experienced by the test charge. Okay, electric field is a force experienced by the test charge. Okay, here electric field is a vector quantity, then force is a vector quantity. The unit of electric field is here force by charge. We know the unit of force is Newton and the unit of charge is Coulomb. So electric field can be written as unit of electric field is Newton per Coulomb, or we can write this one as volt per meter. Okay, see, the definition of electric field is the electric field E at the point P, okay, at a distance R from the point charge Q is defined as force experienced by the unit positive charge, that is a test charge, okay, placed at the point P. It is denoted by symbol F vector is equal to, E vector is equal to F vector by Q0. Okay, electric field is a vector quantity. Okay, then question number 2, that is what is meant by electric field line. Electric field line. Okay, electric field lines are the set of continuous line which are represented by the electric field in region of space, that is known as electric field lines. Okay, see, if suppose I consider a positive charge, from that positive charge the electric field are going outwards. Okay, this electric field lines is visualized by the concept of electric field vectors. Okay, in this region there is a visual representation of electric field that is known as electric field lines. Okay, then short answer question, that is 3 mark. Okay, first question, it is an interesting one. See, the electric field lines never intersect. Justify your answer. Okay, why electric field lines never intersect? That also a question. Okay, electric field lines never intersect. Justify your answer. Question என்ன, எதனால electric field lines intersect ஆகாதுன்னு கேட்குறாங்க, அவ்வளோதான். ஓகேவா, இதுதான் கண்டிஷன். இது ஒரு எலக்ட்ரிக் ஃபீல்டு, இது ஒரு எலக்ட்ரிக் ஃபீல்ட் லைன், இது ஒரு எலக்ட்ரிக் ஃபீல்ட் லைன், இந்த மாதிரி இன்டர்செக்ட் ஆகாது, என்ன ரீசனாலும் இன்டர்செக்ட் ஆகாதுன்னு கேட்குறாங்க. ஓகே, சி, இஃப் two electric field line intersect at a point, okay, this one, okay, intersect at a point P. At that point there will be two different vectors at the same point. Okay, அப்படி intersect ஆனா ஒரே பாயிண்ட்ல ரெண்டு டிஃபரண்ட் வெக்டர்ஸ் இருக்கும். ஓகே, அப்படி இருக்க சாத்தியமே இல்லை. ஓகே, அது நம்ம எப்படி ப்ரூவ் பண்ணலாம் பார்த்தீங்கன்னா, if suppose I am placing a point charge or a source charge at the point P. ஓகே, இந்த Pன்ற பாயிண்டில் அந்த இன்டர்செக்ட் ஆகிற பாயிண்டில் எலக்ட்ரிக் ஃபீல்டு இன்டர்செக்ட் ஆகிற பாயிண்டில் ஒரு சோர்ஸ் சார்ஜை வச்சு அந்த சோர்ஸ் சார்ஜ் என்ன ஆகணும், இட் வில் மூவ்ஸ் இன் டூ டிஃப்ரெண்ட் டைரக்ஷன் அட் சிங்கிள் இன்ஸ்டன்ட். ஒரே டைமில் ரெண்டு டிஃப்ரெண்ட் டைரக்ஷன் மூவ் ஆகணும். அப்படி மூவ் ஆகாது, அதனால் எலக்ட்ரிக் ஃபீல்ட் லைன்ஸ் என்ன ஆகாது, intersect ஆகாது. ஓகே, see, if two electric field line intersect at a point, then there will be two electric field vectors at the same point. ஒரே பாயிண்ட்ல ரெண்டு field vectors இருக்கும். ஓகே, அப்படி இருக்காது. அதை எப்படி சொல்லலாம், as a consequence, if some charge is placed at the point, இந்த பாயிண்ட்ல ஒரு சார்ஜ் வைக்கிறேன், வச்சா அது என்ன ஆகணும், it has to move in two different directions. ஓகே, இந்த பக்கம் மூவ் ஆகணும், இல்லை இந்த பக்கம் மூவ் ஆகணும், அது ரெண்டு பக்கமே மூவ் ஆகும். அப்படி மூவ் ஆகுமா, அப்படி மூவ் ஆகாது. ஓகே, அதனால் என்ன சொல்கிறாங்க, which is physically impossible, hence electric field lines never intersect. அதனால் electric field lines என்ன ஆகாது, intersect ஆகாது சொல்கிறாங்க. ஓகேவா, then next என்னன்னா, next question, define electric field and discuss its various aspects. electric fieldனா என்ன, அதனுடைய அம்சங்கள் என்னன்னு கேட்டிருக்காங்க, அவ்வளோதான். electric field, we know very well, electric field is a force experienced by the unit positive charge. ஓகே, எலக்ட்ரிக் ஃபீல்டுக்கான டெஃபினிஷன் அப்படியே எழுதிட வேண்டியதான், அதனுடைய aspects மட்டும் பார்ப்போம். இம்பார்ட்டன்ட் aspects ஆஃப் எலக்ட்ரிக் ஃபீல்டு. aspects of electric field. See, first aspect, if suppose I consider a positive charge, எப்போதுமே எலக்ட்ரிக் ஃபீல்ட் லைன் பாசிட்டிவ் சார்ஜ்லேருந்து ஸ்டார்ட் ஆகும், நெகட்டிவ் சார்ஜில் போய் டெர்மினேட் ஆகும். ஓகே, ஃபார் ஏ பாசிட்டிவ் சார்ஜ் எலக்ட்ரிக் ஃபீல்ட் இஸ் பாயிண்ட் அவே ஃப்ரம் த பாசிட்டிவ் சார்ஜ். ஓகே, ஃபார் நெகட்டிவ் சார்ஜ் எலக்ட்ரிக் ஃபீல்ட் tend towards the negative charge. Okay, then next point, if electric field at the point P is E, then the force experienced by the test charge Q0 placed at the point P is F vector is equal to Q0 E vector. Okay, நம்ம முன்னே பார்த்தோம், அந்த டெஸ்ட் சார்ஜ் எக்ஸ்பீரியன்ஸ் பண்ணுற ஃபோர்ஸ் ஒரு எலக்ட்ரிக் ஃபீல்டில், இதான் ஒரு எலக்ட்ரிக் ஃபீல்டு. இந்த பாயிண்டில் நான் என்ன பண்ணுறேன், ஒரு சோர்ஸ் சார்ஜ் வைக்கிறேன், Q0 சோர்ஸ் சார்ஜ் வைக்கிறேன். இந்த பாயிண்டில் எலக்ட்ரிக் ஃபீல்ட்னா ஈன்னு இருக்குது, இதில் வச்சா இந்த சார்ஜ் என்ன ஆகும், இட் எக்ஸ்பீரியன்ஸ் எ ஃபோர்ஸ், தட் ஃபோர்ஸ் இஸ் F vector is equal to Q0 E vector. இந்த ஈக்குவேஷனை என்னன்னு சொல்லலாம்னு பார்த்தீங்கன்னா, கூலம்ஸ் லா இன் டேர்ம்ஸ் ஆஃப் எலக்ட்ரிக் ஃபீல்ட். ஓகே, கூலம்ஸ் லா இன் டேர்ம்ஸ் ஆஃப் எலக்ட்ரிக் ஃபீல்ட். Okay, the next point, electric field is independent of the test charge Q0 and depends only on the source charge. electric field எதை டிபெண்ட் பண்ணி இருக்காதுன்னு பார்த்தீங்கன்னா, டெஸ்ட் சார்ஜை டிபெண்ட் பண்ணி இருக்காது. ஓகே, எந்த சுச்சுவேஷன்லாம் ஆல்வேஸ் த சோர்ஸ் சார்ஜ் இஸ் கிரேட்டர் தென் டெஸ்ட் சார்ஜ். இந்த சுச்சுவேஷனில் எலக்ட்ரிக் ஃபீல்டு எதை டிபெண்ட் பண்ணியிருக்காது, சோர்ஸ் சார்ஜை டெஸ்ட் சார்ஜை டிபெண்ட் பண்ணியிருக்காது. ஓகே, see next point, since the electric field is a vector quantity at every point in space, the field has a unique direction. Okay, electric field என்றது என்னன்னா வெக்டர் குவான்டிட்டி, அதனால் ஒவ்வொரு பாயிண்ட்லேயும் ஒவ்வொரு டைரக்ஷன் இருக்கும்னு சொல்கிறாங்க. ஓகே, இந்த பாயிண்ட்ல இந்த டைரக்ஷனில் இருக்கும், இந்த பாயிண்ட் கன்சிடர் பண்ணால் இந்த டைரக்ஷனில் இருக்கும்னு சொல்கிறாங்க. ஓகே, தென் இந்த கண்டிஷன் நான் சொல்லிட்டேன், the test charge is made sufficiently small such that it will not modify the electric field of the source charge. Okay, ஒரு source charge உடைய எலக்ட்ரிக் ஃபீல்டை எது மாடிஃபை பண்ணக்கூடாது, டெஸ்ட் சார்ஜ் மாடிஃபை பண்ணக்கூடாது. அப்போனா எப்போதுமே எப்படி இருக்கணும், சோர்ஸ் சார்ஜ் இஸ் ஆல்வேஸ் கிரேட்டர் தென் டெஸ்ட் சார்ஜ். ஓகே, தென் த எக்ஸ்பிரஷன், ஓகே, தட் இஸ் E vector is equal to 1/4 pi epsilon naught Q by R square. Okay, this is the expression for the electric field experienced by the point charge. Okay, then for a continuous charge distribution we use என்ன யூஸ் பண்ணணும் பார்த்தீங்கன்னா, சூப்பர் பொசிஷன் பிரின்சிபல் யூஸ் பண்ணணும். ஓகே, தென் நெக்ஸ்ட்டு uniform and non-uniform electric field. Okay, uniform electric field na onnu illappa kavani. Uniform electric field இதை வெக்டர் போட்டிருக்காங்க. இந்த ஆரோ ஹெட் எதை இண்டிகேட் பண்ணுதுன்னா டைரக்ஷன். ஓகே, இது என்ன இண்டிகேட் பண்ணுதுன்னா மேக்னிடியூட். ஓகே, நமக்கு தெரியும் வெக்டருக்கு என்னென்ன இருக்கணும், டைரக்ஷன் as well as magnitude. ஓகே, for uniform electric field the direction and the magnitude are same. ஓகே, கான்ஸ்டன்ட் மேக்னிடியூட் எல்லாமே பாருங்கள், கான்ஸ்டன்ட் மேக்னிடியூட் எல்லாமே ஒரே டைரக்ஷன் தான். அது என்ன, இது யூனிஃபார்ம் எலக்ட்ரிக் ஃபீல்ட். ஃபார் நான் யூனிஃபார்ம் எலக்ட்ரிக் ஃபீல்ட் மேக்னிடியூட் மாறலாம், மேக்னிடியூட் மாறினாலோ இல்லை டைரக்ஷன் மாறினாலோ. ஓகே, அதை என்ன சொல்லலாம் நம்ம, இட் இஸ் நோன் அஸ் நான் யூனிஃபார்ம் எலக்ட்ரிக் ஃபீல்ட். ஓகே, our next subtopic, that is electric dipole and its properties. Okay, electric dipole. First of all, we have to know what is electric dipole. So I am considering this question first. Okay, then let me move for the general definition of electric dipole moment. Okay, first of all we need to know what is electric dipole. That is short answer first question. Okay, electric dipole, this is simply stated as two equal and opposite charge. Okay, see, I am considering two equal and opposite charge. Okay, this is minus q, this is plus q. Two equal magnitude in charge, but the sign will be different. Okay, here it is a negative charge, it is a positive charge. Two equal and opposite charge are separated by a small distance. Okay, that is a overall distance is 2a. This constitute electric dipole. This is known as dipole. Two equal and opposite charges separated by a small distance constitute electric dipole. Okay, example for this, CO H2 NH3. Okay, these are the example for electric dipole. Okay, then one more thing is they asked, give the expression for magnitude of its electric dipole moment and its direction. Okay, expression for magnitude of dipole moment. Okay, we need to know what is dipole moment. Dipole moment. Okay, P is a dipole moment. Okay, P is equal to Q into 2E. Okay, we can simply state as the magnitude of dipole moment. P is a dipole moment, that is equal to product. Okay, here it is multiplying Q, the charge and the distance are multiplying. So the magnitude of the dipole moment is equal to product of magnitude of the charge and the distance between the two charges. Okay, this can be written in vector form, that is P vector is equal to 2 QA into I cap. Okay, this is a magnitude. Okay, then the direction of the dipole moment is always from negative to positive. Okay, direction of dipole moment is from negative charge to positive charge, and here it is a which quantity, vector quantity. Okay, then let me go for the very short answer question. Okay, that is first question. Write the general definition of electric dipole moment for the collection of point charges. Okay, if suppose I consider a system having n charges, for that system we need to calculate the electric dipole moment. For that we need the definition, that is expression, that is P vector is equal to, okay, small p, P vector is equal to summation of I is equal to 1 to n charges Qi Ri vector. Okay, here Ri vector is a position vector of the charge Qi. Okay, then next question, that is long answer question, very important question. Calculate the electric field due to the dipole on its axial and equatorial plane. Okay, let me see one by one. Okay, first one is axial line. That let be followed by that we will see the equatorial plane. Okay, first question, we need to find the electric field due to an electric dipole at the point on its axial line. Okay, it is one of the easiest question ever to find the electric field due to an electric dipole at the point on its axial line. Okay, so we need to find the electric field for the dipole on its axial line. Okay, so I am considering a dipole. We know dipole is a two equal and opposite charges separated by a small distance. Okay, so I am considering minus q, okay, then plus q, get separated by a small distance, that is 2a. Okay, here it is the center of the dipole, here a, here also a. Okay, we need to find the electric field due to the dipole on its axial line. Okay, it is an x-axis. On that point we have to calculate the electric field. Okay, so I am considering the point C in its axial line. C is a point at a distance r from the center of the dipole. Okay, then we know the direction of the dipole moment is from negative to positive. Okay, this is p vector. Okay, first of all we have to find the electric field at a point C due to the charge plus q. Okay, because plus q is nearer to the point C. Okay, electric field due to plus q, that is E plus vector. Okay, that is equal to, we know, 1 by 4 pi epsilon naught q1. Okay, that is the charge value is q by distance. What is the distance between the charge and the point C? That is r minus a. Correct? Okay, we need this distance only, so r minus a, then r minus a whole square. Okay, here it is in vector quantity. Okay, so we need to indicate the direction of the electric field. That is in the, we know the electric field is always start from positive charge. Okay, so it will move away from this charge. Okay, so the direction of the electric field is from I am considering this one as A, this one as B, is along BC. Okay, along BC. We know the dipole moment is in the direction BC. Okay, dipole moment is also from negative to positive, so it is in the direction of BC. So I am written this one as E plus vector is equal to 1 by 4 pi epsilon naught q by r minus a whole square, that is p cap. Okay, this electric field is E plus. Okay, then E minus, the electric field due to negative charge, that is equal to 1 by 4 pi epsilon naught, the value of the charge is minus q. Okay, then divided by the distance between the charge and the point C is r plus a. Okay, r plus a whole square. Okay, here it is in the direction opposite to E plus, because it is a negative charge, E minus. Okay, so we can write that one as p cap. Okay, minus p cap. Okay, modifying this we get E minus vector is equal to q by 4 pi epsilon naught r plus a whole square minus p cap. Okay, we know the point C is very closer to the charge plus q. Okay, so the distance is less, so electric field is more. Okay, then the magnitude of electric field is more, but the point C is at a distance, greater distance from the point charge minus q, then the magnitude of electric field is less comparing with the E plus. Okay, see, we want to find the electric field at the point C due to the dipole. Okay, so we are using the superposition principle. Okay, using superposition principle we can write E total vector at the point C is equal to E plus vector plus E minus vector. Okay, then substituting the known values, that is E plus vector is equal to, we know, 1 by 4 pi epsilon naught q by r minus a whole square into p cap. Okay, plus, okay, this is minus q by 4 pi epsilon naught r plus a whole square into p cap. I am taking the minus here. Okay, so it is minus, then this plus became minus, then E total vector is equal to q by 4 pi epsilon naught r minus a whole square p cap minus q by 4 pi epsilon naught r plus a whole square p cap. Okay, taking the constant terms out, then we get q by 4 pi epsilon naught, we get 1 by r minus a whole square minus 1 by r plus a whole square into p cap. Okay, then again solving this, then we get E total vector is equal to q by 4 pi epsilon naught, LCM, taking LCM on this bracketed term, then r plus a whole square minus r minus a whole square by, solving this we get r square minus a square whole square, okay, into p cap. Okay, then solving this, E total vector is equal to q by 4 pi epsilon naught, that is r square plus a square plus 2ra minus, this one became r square plus a square minus 2ra. Okay, then divided by r square minus a square whole square into p cap. Then E total vector is equal to, we get q by 4 pi epsilon naught, and solving this we get r square cancelled, a square cancelled, then we get 4ra by r square minus a square whole square into p cap. Okay, see here, if suppose I consider the point C that is taken far away from the dipole. Okay, C is taken far away from the dipole, then the distance r is greater than a. Okay, here the situation, I am considering the point C is taken far away from the dipole, then r is greater than a, so a can be neglected. Okay, this term, okay, a can be neglected. Then E total became q by 4 pi epsilon naught ra by this a power 4 is neglected, then r power 4 p cap. Okay, then cancelling this we get E total vector is equal to q by 4 pi epsilon naught 4a by r cube p cap. Okay, we know the dipole moment, that is p is equal to q into 2a. Okay, so we can modify this as E total vector is equal to q into 2a into 2, okay, divided by 4 pi epsilon naught r cube into p cap. Okay, so we can write this one as p. Okay, then E total became 2p here p cap by 4 pi epsilon naught r cube. Okay, we know a unit vector is a vector divided by its magnitude. Okay, so p into p cap is equal to p vector. Okay, so we can write this one as E total vector is equal to 2 p vector by 4 pi epsilon naught r cube. Okay, this will shows the total electric field at the point C is equal to the direction of the dipole moment. Okay, see, the dipole moment is in the direction from A to C. Always also the direction of the net electric field at the point C, E total, that also in the same direction of dipole moment. Okay students, practice the questions that are taught by today. In tomorrow's class, let me see the electric field into electric dipole in its equatorial plane and torque experienced by the electric dipole. Okay, thank you.